In this video, we're going to talk about some specifics with conversions when we're going from moles to atoms and atoms to moles. So in class the other day, you learned about these two different formulas for converting from the number of moles to atoms and also from the number of atoms to the number of moles. The top one we use when we're going from atoms to moles, and the bottom one we use when we're going from moles to atoms. So while these formulas are pretty straightforward, there's a couple different things that we need to keep in mind when we go over these particular topics. So if we go way back and we think about the water molecule, we remember that the water molecule is made up of two hydrogens and one oxygen. We call this the compound of water, but we can also say that it's a water molecule. A water molecule refers to the three different atoms that make up this molecule. So again, the three atoms that make up this molecule are two hydrogen atoms and one oxygen atom. Every single water molecule has to have two hydrogens and one oxygen. So if I had 5 molecules of water, how many hydrogen atoms would I have and how many oxygen atoms would I have to have? We can see, or we can count on the screen, that if I had 5 molecules of water, I would also need to have 2 hydrogens for each one, which would give me 10 hydrogen atoms total for all 5 of these molecules. For oxygens, I only need 1 for each molecule, so 5 molecules of water means I need 5 oxygen atoms. Now we're looking at this on a really small scale when we think about 5 atoms, but we could also think about having a mole of atoms or a mole of this molecule. So if we have a mole of the molecule of water, like maybe the amount that's in this container right here, that means that we would have 6.02 times 10 to the 23 molecules of water. That's the same thing as saying we have 1 mole of water. That would be like saying if I wrote out each of these 5 and then I actually wrote out 6.02 times 10 to the 23rd. Now, if we think about having that many molecules of water, we also should think about how many atoms we have of oxygen and hydrogen. So how many atoms of hydrogen would be in 6.02 times 10 to the 23rd molecules of water? For each molecule, we know we have 2 hydrogen atoms. So we can simply multiply 6.02 times 10 to the 23rd. We can multiply that by 2, and we know that we would have 1.2 times 10 to the 24th atoms of hydrogen, which would be the same as saying that we had 2 moles of hydrogen. Now, the math there seems complicated because we're using such a big number, but remember that's the exact same thing that we did when we multiplied the number of hydrogens by 5 for these 5 molecules. Same thing here when we're multiplying by the number of molecules in a mole. It's a little more simple for oxygen because in oxygen we have 1 oxygen per molecule. So that means that we multiply this number by 1 and we say that there are 6.02 times 10 to the 23rd atoms of oxygen, which is the same as 1 mole of oxygen. So here's a practice problem for us to think about with this in mind. So what's the total number of moles of atoms contained in 1 mole of NH3? So if we think about it, 1 mole of NH3 is going to have 1 mole of nitrogen to make it up, and it's also going to need 3 moles of hydrogen. I know that because of this 3 that comes as a subscript after my hydrogen. If I add this up, it means we have to have a total of 4 moles of atoms in order to get 1 mole of the molecule NH3. Here's another practice problem for you to try. What's the total number of moles of hydrogen atoms contained in 1 mole of this big compound? When we look at this, 1 mole of this big compound, we're just focusing in on the hydrogens. The hydrogens I know I have 4 of in this polyatomic ion, and then there's 2 of those polyatomic ions. That means that I have 4 times 2, which is a total of 8 moles in order to get 1 mole of this compound. We can also look at this in terms of methane molecule. The methane molecule is made up of 4 atoms. There's 1 atom of carbon and there's 4 atoms of hydrogen. So how many molecules make up 1 mole of methane? We need 6.02 times 10 to the 23rd molecules in order to get 1 mole of methane. But if we think about that in terms of the actual atoms, we're going to have 1 mole of atoms of carbon, and we're going to need 4 moles of atoms of hydrogen because we have 1, 2, 3, 4 atoms of hydrogen for every 1 molecule of methane. So here's some general rules when we're thinking about this. If you see the word molecules, you're determining the total number of molecules overall. So you can just use that same formula we talked about at the beginning and multiply by the number of moles. However, if you see the word atoms, you need to be a little more careful and you need to determine the number of atoms in that particular compound. Here's 2 more examples. How many molecules are in 0.25 moles of CO? I see the word molecule, so I'm not worried about atoms, and I can use this simple equation. The number of moles times 6.02 times 10 to the 23rd is going to give me the number of atoms. Excuse me, it would give me the number of molecules. That's important, right? So this is going to be 1.5 times 10 to the 23rd molecules. On the other hand, for this question, it says, what's the total number of nitrogen atoms in 0.25 moles of NO2 gas? So here we want to think more about our particular atoms. When we're looking at this, nitrogen, we just have 1 atom per molecule. So we can say that we have 0.25 times 6.02 to the 23rd molecules. And that's going to be equal to 1.5 times 10 to the 23rd atoms for nitrogen. If this question was rephrased and it said what's the total number of oxygen atoms, then we would do the same math, but at the end we would multiply by 2 because we see this little 2 here next to the oxygen. I hope that this has been helpful. Please continue by working on the practice worksheet to make sure that you're feeling confident in this topic.